Okay, so we started using the rectangular model to expand each of the following. You guys actually took a quiz over this on Friday, and you guys did a really nice job on it. I apologize that my opener here is getting cut off. But what's the first number or set of numbers represent? The height. And the second number or group of numbers represents the? So my first height is going to be 3A. I am going to put that right on the inside here, just because mine's cut off. Okay, and what's the first width going to be? And the second width? -5. Once I know the height and the width, the next thing I'm going to find is each section's what? Area. So I'm going to come in, I'm going to use area equals, what's my formula? What's my formula?
Oh, 3A.
No, what's my formula? You're doing it right. You're just plugging the numbers in. What's the formula for area? Area equals?
Height times width.
Okay, area equals height times width. Good. And you were saying my height was 3A and my width is what, Daisha?
2A.
Which equals?
6A to the second.
Nice. 6A to the second, or 6A squared. Okay, the area of the second section is going to be what times what?
Height times width.
Which is?
3A times -5.
Which equals then?
Want to be like -15?
-15A. Good. So once I have the area of each section, I want to find the total area of the entire model. So I'm going to go ahead and add. But I can only add or combine if they're like terms. Do I have any like terms up here? No. So then how do I know which one to put first?
6A.
Why do you do the 6A squared first?
I don't know.
Can somebody tell me why I do the 6A squared first, Cody?
Because it's larger than -15A.
Close.
Go ahead, what?
The larger something or greater something's right.
Between.
But what am I looking at to determine what I put first?
Least.
Least to greatest, but I'm going to flip it and do greatest to least based on the,
Number.
what number? Second? Did you say it?
Yeah.
The exponents. So the variable with the largest exponent is the one that we start with, which was 6A squared. And then my other number that I have left is -15A. So there's my final answer. When you guys get into the 4 con topics that I assigned you, you're going to have exponents that are larger than A squared. You're going to have like A to the 6th, to the 5th, to the 4th. So it's important to remember you're going to put them in order based on the variable with the largest exponent. Okay, next one here. What's my height for each section of these, Danielle? And then my second height? Good job. And then what's the width? And then the width of my second section. Now, this one's a little bit different because my first height didn't have a variable. But it's okay. We're still going to drop them down in order. All right, Jaden, go ahead and find the area for the top left section for me.
A equals 3 times 4C to C.
David, top right.
Okay, which one? What was
Top
that?
right, right here.
Oh, what's that? A equals 3 times -1. All right, -3.
Perfect. Bottom left, Kaylon.
-2.
2C, right?
Yeah.
Times,
+4. C.
which equals?
Equal -8. C. C second square.
Nice.
Second power.
Yes. And bottom right, AJ.
I'm still writing first. That's
Jaden. I already called on you. Who had I heard from? Daisha.
A times 2C times -1. So what would that be? -2?
Well, it's -2C times -1. So what's 2 negatives equal? 2 times 1 is?
2.
And then my variable?
C.
All right. From here, we're going to identify our like terms. Okay? What are my like terms here? Deja?
2C and 2C.
Okay. This time, you guys notice they're in different sections. It's all right. We're still going to go ahead and combine like terms the same way that we had. So which number do I start with?
What you mean?
What's the first part of my answer here?
Oh, that's 8.
So negative 8c because it's the one with the largest exponent. Then what?
You gonna add 12 and 2 together?
Good. So I'm going to combine my like terms. 12c plus 2c, which is,
14C.
and then
Negative 3.
-3. Good. It's kind of all.
What is that? I can't even tell. Negative 8. That kind of looks like an H. Oh, it's 14C.
Oh, I could maybe see how you got that, but
So negative 8.
sorry.
C squared. Plus 14C minus 3.
All right, y'all have it?
Yeah.
Okay. Now flip it over. Now the back side of your opener, you're going to have find the greatest common factor of the following terms. Now, we on, gosh, what day was that? Thursday, we did not finish that part of the notes. We got to where we found the greatest common factor, but we really didn't focus too much on the variables, okay? So when we found the greatest common factor, the first thing is we use the factor tree to find the greatest common factor or the common factors of the numbers. So we're going to do a factor tree for 600 and a factor tree for 450. So a factor tree is where we think of what two numbers can I multiply together to get 600. So what are two numbers I can multiply together to get 600?
6 and 100.
Okay, so we're going to use 6 and 100. Do you have to start with those two factors?
No.
No. Okay, for 6,
You do 6 and 2.
how about 2 and 3? There we go. And then
for 100, you can do 10 and 10. Then you can do for 10, you can do 5 and 2. Then the other one, you can do the same thing.
okay.
You right up.
Hold on, give me a second. Good. So, if you use like 60 and 10, or you use something different for 600, the main thing is our prime numbers should all be the same. Okay? So then for 450, Danielle, what are two numbers I can multiply together to get 450? Ends in a 0. Okay. So, well, if it ends in a 0, I would use 10. And then if I take that 0 off, what am I left with? So 10 and 45. We already know the factors for 10 are 2 and 5. What about for 45, you guys? What are two factors of 45? What two numbers? Say 5 and 9. Good. 5 is prime, so I circle it. What about for 9?
3.
So I circle them. So now I drop down. Next to the 600, I'm going to list my prime numbers in order from least to greatest. So when I list these in order from least to greatest, I'm going to write out 2 times 2 times 2. So I use that, times 3 times 5 times 5. Okay? What are my prime numbers I'm going to write out for 450?
2 times 3 times 3 times 5.
Okay. Who remembers what to do from here? What's the next step that I'm going to do here? Deja? Yeah, I'm going to circle the numbers that 600 and 450 have in common. So what numbers do they have in common?
2,
Okay, so they have a group of 2s,
and 3.
they have a group of 3s, and a group of 5s. Is that it? Is that all they have in common?
No, it's another 5.
Another group of 5s. So my greatest common factor is going to be they share a 2, they share a 3, they share a 5, and another 5. So we're going to have to multiply those factors together. So 2 times 3 is, 6 times 5 is
Ain't like 30.
30. Then what's 30 times 5? Close.
You said 3 times 50?
3 times 5, 150.
I said 50.
Okay, But we're not done. What haven't I included in this? The variables, right? There's two ways to do this. Okay? I'm going to show you the long way first, and then I'm going to show you the shortcut. And we're going to learn both today. But I want to show you the long way so you can visually see what I'm talking about. So what I would do with this is, how many m's do I have for 600? So I'd write that out like that. How many n's do I have? Okay. How many m's do I have for 450? And how many n's do I have?
2.
Okay. So what I would do, circle how many they have in common. Okay. So how many m's do they have in common? How many m's do they have in common?
2.
So it'd be m squared. How many n's do they have in common?
1.
So they only have 1 in common. So the greatest common factor for these two numbers is going to be 150 m squared n. Now, writing out your variables like that is going to take us some time, because sometimes you might have the variable to the 15th power. Do you really want to write m 15 times? No. So what I do, I look at my variables. Okay, so I have m. Does the other number have m? Does the other term have m? Yes. Which exponent is smaller, to the third or to the second? That's the one you use. That means they only have 2 in common, hence m squared. Then I look at my next variable that they have. Do they both have an n?
Yep.
Which one's smaller, n to the first or just n to the second? To the first is smaller. So that's the one I use, n. But we'll get into that a little bit more in just a minute.